Stan Gibilisco here from the Nerd Cave in the Black Hills of Dakota Territory, United States of America, with a little three-part demonstration and explanation of a device that I have built. Consists of two very simple circuits along with two computers. You can build these circuits very easily yourself, but you will need two computers in order to make it work. They don't have to be expensive computers. The only thing that they have to be able to do is to run a program called Hamscope. Hamscope. Actually, it's Hamscope version 1.56 as of this video. Just Google on that particular word and you will find the Hamscope download site. It runs on my computers on Windows XP, on Windows 7, and on Windows 8. So I have not all of the features of the program actually work, but enough of them work to make this particular project work, and that's all that mattered to me for this demonstration. Here is circuit number 1. If you've looked at this for a while I've been yammering in the introduction here to this little ditty, you may get the idea that this is a device intended to transmit modulated light signals from your computer through a light-emitting diode and out into space. And if you're of that mentality, that is absolutely right. There is the heart of this device right here. You take the audio output of your computer. Right down here, the headphone output is an ideal place to get that. Run it through an audio cable. It has to be a shielded audio cable, and it really helps a lot if your computer has a good ground connection. Normally, if it's a desktop unit, it will, especially if you have a 3-wire cord. If it's a notebook computer, though, you might want to go to a little bit of trouble to connect the shield of this cable to some kind of a good electrical ground connection. That'll really help this circuit here. Then you provide this light-emitting diode with some voltage, some working voltage, and you do that with a battery, and I used a 6-volt battery and a 1500 ohm resistor to keep that, first of all, to keep that diode from reaching quite full brilliance. You don't want it to be completely saturated. You want it to be maybe 50 or 60% of its full brilliance, so that the audio that comes out of here, that comes out of your computer's headphone output, passes through this 1 microfarad capacitor. This capacitor right here will block the DC so that the DC from your battery doesn't get into your computer and mess things up, and it will also prevent your computer's output, your headphone output of your computer, from shorting out this diode in the event that this is a transformer at your computer's output. Some computers and audio amplifiers have transformer outputs, and that could short out this diode and extinguish it when you connect this directly. So that 1 microfarad capacitor right there is enough to let the audio through, the audio impulses through, but it will block direct current, and then that audio will modulate the light that this diode emits, particularly if it's only about halfway lit by the battery in this resistor, so it can get brighter and dimmer and brighter and dimmer and brighter and dimmer with audio impulses. Now, what are you going to modulate this with? Well, you can modulate it with just about anything. You can modulate it with voices, you can modulate it with music, but I'm going to modulate it with a specific type of audio tone signal called phase shift keying 31. Phase shift keying, PSK. 31 refers to the speed of the signal. I guess it's about 31 words a minute. It is a ham radio digital mode that the program called Ham Scope is specifically designed to generate and also to demodulate. So what you're going to get is modulated light out of this diode that is modulated with this PSK 31 audio signal, and it'll be at about 1500 hertz. That is the standard frequency that I like to use, 1500 hertz, sort of a tweet type of pitch. You'll hear it when I conduct the demonstration of this system. So that is the modulated light transmitter. Now I'm going to show you the receiver. Very similar circuit. It has a 6-volt encapsulated solar module. You can get these things at Radio Shack. That is like a photovoltaic cell, a PV cell, otherwise known as a solar cell. And the reason the 6-volt specification means that it'll produce 6 volts of direct current in direct intense sunlight. Once again, you have a computer with a good ground connection. You have this plug, but instead of plugging it into the headphone output of your computer, you plug it into the microphone input. Now, you're going to need to adjust the audio level of your microphone input so that it isn't too sensitive, it doesn't get overwhelmed, and yet so that it's sensitive enough to pick up those modulated light signals. This solar cell will respond not only to the light itself coming off of that light-emitting diode, the steady light, but it will also produce a fluctuating output voltage and a fluctuating output current that goes right along with those modulations on the light-emitting diode, particularly if this solar cell is not saturated by direct sun shining on it. You don't want to have a brilliant light shining on this thing while you're testing this circuit. You also want to avoid incandescent or fluorescent or any type of utility light bulbs from shining on this thing when you're doing your experiment, because the 60 hertz, actually it's going to be a 120 hertz modulation of the light coming out of your light bulbs, even incandescent bulbs. And it'll make a buzz, a hum, like a buzz that will interfere with your reception. So your best bet is to avoid having other light sources shine on this at all. You'll shine that light-emitting diode right on it, and if you get one with a little lens in it, like you can find at Radio Shack, little light-emitting diode with a lens, then you can just aim it right at this over a distance of a few feet. You want to keep this wire right here short so that it doesn't pick up a lot of utility hum. Utility wires produce electromagnetic fields at 60 hertz and harmonics thereof, and it'll create a lot of garbage in your receiver if you have too much exposed wire. That's why you need a good ground connection at your computer to help this cable so that it is really shielded and will keep that hum out of your computer. This capacitor right here keeps the DC from the battery from getting in and messing up your computer's microphone input. It only allows the audio impulses, that is the fluctuations, to get through, and it also, because you'll notice it's a little less than the capacitance that I used in the transmitter circuit, and the reason for that is that this particular value of capacitance will discriminate against the lower frequencies down near 60 Hertz, where the most hum from your utility wires and incandescent bulbs, 60 and 120 Hertz. It'll help to attenuate some of that, and will focus more on your on the audio around 1500 Hertz that you want. So that is your receiver. I've shown you now schematic diagrams of the transmitter and the receiver for modulated light signals, and this will take PSK31 and run it into another computer that is also running that program called ham scope, and you'll want to set this ham scope program for BPSK. Bravo. What's the phonetic for P? I've forgotten. My gosh. BPSK31 is what you'll want to use for both the transmitter and the receiver, and you'll want to set it at 1500 Hertz. So those are the schematics. Now I am going to, in part 2, I will show you the physical devices themselves that I have constructed and what they look like. Until part 2, Stan Gibilisco signing off, saying so long for the moment.